everyone, welcome again to another video of Making Math Easy for Better Understanding. Still, this is your teacher Hazel, and for today's video, we will tackle about partial fraction decomposition on non-repeating linear factors. First, let us define what is linear factors. The first-degree equations that are the building blocks of the more complex and higher-ordered polynomials. And also, let us always remember that linear factors appear in the form of ax plus b and cannot be factored further. And now, since we are tackling about partial fraction decomposition and non-repeating linear factor, let us know how we could do that. So, if a linear factor ax plus b occurs once as a factor of the denominator of the given fraction, then corresponding to this factor, associate a partial fraction, which is denoted in a over ax plus b, where a is a constant not equal to 0. So let us have an example. First, let us have 6x minus 22 all over 2x squared plus 7x minus 15. So we could factor out the denominator as 2x minus 3 times the quantity of x plus 5. So we could write it in a form of 6x minus 22 all over the quantity of 2x minus 3 multiplied to the quantity of x plus 5. Another example for that is 2x minus 3 all over x squared plus x. We could factor the denominator as x times the quantity of x plus 1. So we could write it in the form of 2x minus 3 all over x times the quantity of x plus 1. Now, let us have the first example, which is the 6x minus 22 all over 2x squared plus 7x minus 15. So just what I've done earlier, let us find the factor of the denominator. So that would make the equation 6x minus 22 all over the factors, which is the 2x minus 3 multiplied to the quantity of x plus 5. Then to get the partial fraction, the factors of this equation, let us equate it to a over the first factor, which is the quantity of 2x minus 3, plus b over the second factor, which is x plus 5. Then to solve, let us multiply both sides of the equation to the least common denominator, which is 2x squared plus 7x minus 15. Then multiply the LCD to the both sides of the equation. So that gives us 6x minus 22 equals a times the quantity of x plus 5 plus b times the quantity of 2x minus 3. So why is that? Since we are going to multiply 2x squared plus 7x minus 15 to the numerator, which is 6x minus 22, then divide it with the denominator. So just cancel the common factors. So then, using the distributive property, that gives us 6x minus 22, so a times x, that gives us ax, plus a times 5, that gives us 5a. Then, distribute also b, so that gives us 2xb minus 3b. And then, combine like terms, so that gives us 6x minus 22. So just copy the equation, the equation in the left side, then combine like terms in the right side of the equation, so that gives us ax plus 2xb plus 5a minus 3b, and then factor out. That gives us 6x minus 22. So factor out ax plus 2xb, so that gives us x times the quantity of a plus 2b. And then plus factor out also 5a and minus 3b. So since there are no common factor, and we cannot factor that out, so just leave it as 5a minus 3b. So then equate the left side of the equation to the right side of the equation. So the coefficient of x, which is 6, equate it to the coefficient of x on the right side, which is a plus 2b. So that gives us a plus 2b equals 6. Then also the constant on the left side and the constant on the right side will also be equated. So that gives us 5a minus 3b equals negative 22. Now we have two systems of equation, which is the a plus 2b equals 6 and 5a minus 3b equals 22. So for us to solve for the values of a and b, let us solve it using the elimination method. So first, let us multiply the first equation into to 5, so that we could eliminate 5a in the second equation. So that gives us 5 times a plus 2b equals 6. And that would be equal to 5a plus 10b equals 30. So just write the second equation below the first our modified first equation. So that gives us 5a minus 3b equals negative 22. So just subtract the second equation from the first equation, so that would cancel out the 5a on both equation, and then 10, and then the negative 3b will be a positive 3b, so that gives us 13b equals 52. So to get b, the value of b, divide both sides by 13, so to cancel out 13, so we will be given at b equals 4. So we will, as of now, we have a value for b. So to solve for a, just substitute the value of b to the equation. So that gives us, we will be using the first equation, which is a plus 2b equals 6. So that gives us a plus 2 times the value of b, which is 4, equals 6. So that gives us a plus 8 equals 6. Then using the additive inverse property, 8 would be subtracted from 6. So 6 minus 8, then we get our value of a, which is negative 2. And now, since we have values for a and b, we could now write or get our partial fraction decomposition of 6x minus 22 all over 2x squared plus 7x minus 15. Equate, that would be negative 2 over the first factor, which is 2x minus 3, plus the value of b, which is 4, as the numerator. Then the denominator will be the second factor, which is x plus 5. Now we have our answer. Now let us have another example of 2x minus 3 all over x squared plus x. So just same as the first example, let us factor out first the denominator. So that is x times the quantity of x plus 1. So then equate to a over the first factor, which is x, plus b over the second factor, which is x plus 1. Then multiply the both sides by their LCD, which is the x times the quantity of x plus 1. So that gives us 2x minus 3 times x times the quantity of x plus 1 all over x times the quantity of x plus 1 equals a times the quantity of x multiplied to the quantity of x plus 1 over x plus b multiplied to the quantity of x times the quantity of x plus 1 over x plus 1. And now in here we can clearly see how we could cancel out factors. So we cancel out the quantities of x times the quantity of x plus 1, and then the x in a, and then x the quantity of x plus 1 in b. So that gives us 2x minus 3 equals to a times the quantity of x plus 1 plus b. Then distribute a to x plus 1, that gives us ax plus a plus bx. Then same as the first example, let us combine like terms. So that gives us ax plus bx plus a. So still don't forget to copy the left side of the equation, which is 2x minus 3. So that gives us again 2x minus 3, then equals factor out ax plus b, so that would give us x times the quantity of a plus b plus a. Then equate the coefficient of x in the left and the right side, so that gives us a plus b equals to 2 and a equals to negative 3, which is the constant on both sides. Then since we already have the value for a, which is negative 3, so just substitute negative 3 on the first equation to get the value of b. So that gives us negative 3 plus b equals 2. Then additive inverse, that gives us 2 plus 3. So the value of b would be 5. Now we could get our factors of 2x minus 3 over x squared plus x. So equate it to the value of a over x, which is negative 3 over x, plus the value of b, which is 5 over x plus 1. Now the question is, how would we know if we came up with the right fraction? So just we could check it just by adding the fractions. So to add the fractions, let us find the LCD, which is the x squared plus x. Then divide the denominator of each of the equation to the LCD. So that gives us x squared plus x divided by x, so that would be x plus 1, then multiply to the numerator, which is negative 3. Then same as the first, so x squared plus x divided by x plus 1, so that gives us x, so 5x. And then distributive property, distribute negative 3, so that gives us negative 3x minus 3 plus 5x all over x squared plus x. And then let us combine like terms, so that would be negative 3x plus 5x minus 3 all over x squared plus x. And then negative 3x plus 5x, that would be 2x. Then copy the constant, which is negative 3, all over x squared plus x. And then as you can see, we came up with the given equation, which is the 2x minus 3 all over x squared plus x. So that is correct. And that ends our video for today. I hope that you like it and you enjoyed watching, and I hope that you learned something for today's lesson. Don't forget to like, comment, and share, and hit the notification bell for more updates. Still, this is your teacher, and see you in my